Next up, I want to take a quick look at iterator functions, otherwise known as X functions, in DAX. And in a nutshell, what these iterators do is they loop through a given calculation or expression for each row of a table and then apply some sort of aggregation to the results. Now, here's an example of what a SUMX function looks like. And in this particular case, the aggregation mode is a sum, but the same syntax applies to other X functions like countX, averageX, rankX, etc. So the first argument of the function is the table in which you want the expression to be evaluated. This could be an explicit table reference like sales, or it could be a filter or all function that produces a table. And then the final argument of the function, the expression, is basically what's the calculation that you're trying to evaluate row by row by row. So it might be a measure like total orders, or it might be a mathematical operation like the values in one column times the values in another. And this took a little while to sink in, at least for me. But what kind of helped was to equate it to a sum product in Excel. And a great example that's kind of tangible and hands-on is calculating something like price times quantity, right? So imagine a price column, a quantity column, and you run a sum product, which basically calculates price times quantity in row 1, price times quantity in row 2, over and over and over and over until it gets to the last row in the table. And then it takes the results of each of those multiplication expressions and sums them up. So it might be helpful to think about these iterator functions, adding a temporary column at the end of the table where it stores the results of each of these expressions for every single row as it works through the table. And then once it reaches the end, the final row in the table, it aggregates the values in that temporary column based on whatever function it is. If it's a SUMX, it takes the sum of those results. If it's a countX, it counts the results. If it's a rankX, it determines ranks based on those results, and so on. So that's how these iterators are really working. And to show you an example, what I'd like to do is head back to our AdventureWorks report and try to recreate that revenue column that we had generated with calculated columns and see if we can convert that into a measure using this SUMX function. All right, so open up your Power BI report and head to the Data tab. You want to head to your sales table specifically, and you should see this retail price and revenue column. And these columns were created during the calculated column demos. For retail price, we used related, and for revenue, we simply multiplied the values in the retail price column by the order quantity column. Then as a result, we were able to create a measure for total revenue that equals the sum of that new revenue column. So there's nothing wrong with that. It's not incorrect. We're getting the proper values and it's working just fine. Our table and our data set is small enough that really there's no noticeable impact whatsoever to file size or to speed or anything like that. But if we were perfectionists and we were trying to build the leanest, most efficient possible model that we could, we would try to replicate both of these columns as a measure so that we're not actually stamping redundant data here in the table. So let's see if we can make that happen. I'm going to go back to the report view because we're going to play with our matrix a little bit. And to set up our view, let's keep this view showing category names, but let's just show the quantity sold and the total revenue. So I'm going to get rid of a bunch of these for now and pull in quantity sold, which is a measure, and that total revenue measure as well by product category. Now let's go ahead and add a new measure in our sales table. And let's name that measure total revenue underscore measure, because I want to keep the original so we can compare against it. And let's think about how the original version of total revenue was calculated. We were taking the values from the order quantity column, multiplying by the values of the product price, which we had pulled into the sales table using related. So maybe the instinct is to start with something like that. Maybe we reference the quantity field, and you'll notice that I can't. It doesn't let me. I it can only get to measures here. Same thing with product price. If I try to type price, it's only giving me measure options. And that's DAX reminding us that we can't just reference blanket columns like this. We need to aggregate, because DAX doesn't know what to do with a full column of values and no further instruction. So what if we try to indicate or add the aggregation right here in the formula? So instead of just the quantity column, maybe the sum of the quantity. So sum of AW sales order quantity. It lets us do that. So that's a good start. And let's multiply that maybe by the sum of the product price. You know, if we have to identify some sort of aggregation, maybe that would make sense. So press enter and lock that in. And it seemed to calculate fine. So let's grab this second version, total revenue, pull it into our matrix, and things look totally out of control here. This is telling us that products in the clothing category were sold 12,436 times, total quantity sold, and that generated a revenue of over $22 million, which, just doing the math, means that the average price for a piece of clothing is almost $1,775. So something seems a little bit off there. And as you look at the formula, it's pretty clear that the issue is with our product price field, because we are summing product prices together, which doesn't make any sense at all. We could try to change this to something like an average and probably get a little bit closer. Press enter. So we're at least in the realm of something reasonable, but these numbers are not correct. They're relatively close, but this is not a valid revenue function. So we've got to just chop this down and start over. So if only there were some function that could evaluate an expression for each row in a table and iterate through the whole table and apply an aggregation to the result, that would be exactly what we need here. I think you see where I'm going with this. SumX is going to be a great fit for something like this. So let's start typing it and then walk through. So the first argument of the SumX function is the table, which table contains the rows that we'll be cycling through evaluating these expressions. Well, it's the sales table, AW sales. And the expression, what calculation are we going to be running for each of those rows? It's the calculation for revenue, price times quantity. So we can type quantity, and there you go. Now we can access the actual column itself, order quantity, times the AW sales retail price. Now, one thing you'll note is that I only type price, and there's another price column in the product lookup table. Note that that's not even an option here, and that's because we're performing these row level calculations within the AW sales table. So DAX is telling me I've got to grab columns from within this table. So that's the one I want, AW sales retail price. Close the parenthesis. Now some of you may be wondering, how am I using blanket column references here? AW sales order quantity, AW sales retail price, when we couldn't do that before. The reason is because this is an expression argument of a SumX. And the way a SumX works is that this expression only runs on one row at a time. So I'll never need to aggregate because I'm only looking at a single value from each of those columns each time. Now when we go ahead and press enter, there we go. Everything adjusted. Our new total revenue measure matches the original total revenue measure, and we've done it using a SumX function. So in the spirit of making our model more efficient and reducing redundant data, that means we can now go back to our data, we can right click and delete that revenue column, go back to report. We're going to get an error because that old total revenue measure was built off of the column we just deleted. So we can pull that out of the visual, find it right here in our field list. You can see it's got a little caution exclamation point. You can right click, delete it, and there you go. Our total revenue measure using SumX is still here, still correct, still fully functional, and we've eliminated an entire column of extra data. And now if you want to get really crazy, we can eliminate one more column as well. And I'm going to give you a hint at how we can do that. Looking back at our data sheet, this retail price, remember we pulled this in with related? We can follow this same logic, but embed it or nest it inside of that SUMX that we just wrote, instead of pulling the column in here and then referencing it from within the sales table. So let's go back. I'll show you what that looks like. Total revenue measure, which we can now just call total revenue because the other one's gone. And so SUMX, AW sales, order quantity. Now I told you that we had to pull columns from within that sales table, but I kind of lied. We can access columns from other tables, but the only way to do it is to use the related function. So just like we pulled a related field into the table itself, we can access values from a related field inside of a SUMX. And that related field is the product price. So again, same exact logic as when we used related in the calculated column, except this time we're just embedding it within this SUMX function. And we press enter. Values still hold. Let's go ahead and format those as currency. Perfect. And now the last little step here is to go back to our sales table, and you know it, we can delete this related column as well because we don't even need it anymore. All of the information we need is now built into this single SUMX iterator function. So bottom line, we just chopped out 2 entire columns worth of data without actually losing anything, because we essentially just transitioned the calculations out of columns and into measures. So that's SUMX. The other X functions work in a very similar way. The only difference is the actual aggregation step that happens at the end. But hopefully this inspires you to go and play with some of these iterator functions on your own. Next up, we're going to take a look at an area where DAX really shines, which is time intelligence functions.